today's episode, we're going to talk about a problem I've got in this 2004 Dodge truck. It slowly discharges the battery over a few day period to the point that either you have to jump start it or it cranks real slow. So we're going to have to investigate it, and so I'm going to show you my process here that we do when I work on the vehicles on the farm here, both customer vehicles that do come in occasionally and vehicles that I currently own and equipment. So here's what we're going to go ahead and do is I need to do is check static voltage. The truck sat overnight, so it's been sitting here since yesterday at about the same time. So I got about 24 hours of time sitting. So let's go see what the status of the battery is. So we're going to take our voltmeter and put it on DC volts. We're going to come over here, we're going to hook up, and we're going to see, and we got 12.3 volts. So the battery's heading down there, what, around 60%, maybe a little bit less. So it's drawn down overnight. It's a good battery. I tested it yesterday, so I know there's no problem with the battery. And if you drive, it charges completely up. So we have some kind of a draw that's taking place here, and we have to address. And so we're going to come up with a methodology, and I'm going to share with you the methodology I've used for many, many years, and a tool that I have got recently that has really been beneficial. But before we start looking at that particular tool, what I'm going to do is I need to use the technique that I've used for all these years. What that means is I'm going to take another, in this case here, a small little AGM battery that I use all the time for this kind of purposes, and I'm going to put it in parallel. So what we're going to do is we're going to simply bring the battery over. This one's still intact because I do not, under any circumstances, want to disrupt the modules. Something's going on here, and if I disrupt it, I may not find it. It can be very elusive. I've seen many of these before. So one of the key criteria is, if possible, don't let the battery be fully disconnected and reset all the modules. So here's what we're going to go ahead and do is we're going to hook up to the positive side of the battery, and since I know it's going to be a relatively small current load, I feel safe in just simply going over to the master cylinder here. So at this point here, I have a parallel path. I have a path here from the existing battery, and now I have put another battery in parallel. So at this point here, what I can go ahead and do is I can disconnect this battery and still keep the system completely powered up. We'll grab a wrench and we'll go ahead and disconnect. Put that over to the side. And the next thing we're going to have to do is go get a special tool that I've been used on a couple occasions with great success. It's the Parasitic Draw Test Harness by Snap-on. And what this is going to do to me is save my fuse in my meter. The fuse in my meter has been kind of an ongoing thing. I never know exactly what I'm going to be up against here. So I found that this methodology works really well. It's a great, well-designed tool. Well thought out, I have to say. So what we're going to do is we're going to take the big leads that are hooked to a 15 amp circuit breaker, and I'm going to go ahead and I'm going to hook this in. So we're back in a parallel circuit. So at this point here, I want to make sure the switch is turned on. And with the switch turned on, I've now got up back to a parallel circuit. So at this point here, I can go ahead and I can disconnect temporarily, disconnect my auxiliary battery. And I'm going to take my multimeter and I'm going to hook it up in DC amps. So one lead here is going to go into negative, the other one's going to go into the amp connection. And this also has a level of safety. So I have a 10 amp fuse in here, and I have a 7.5 amp fuse circuit breaker here, and that is going to protect my meter. So we've done a bunch of things. We've protected a car and the integrity of our test with this circuit breaker, and the integrity of our test and our protecting our fuse with this circuit breaker. So at this point here, I'm going to go ahead and switch this over to off. And you can see at this point here, we've got a significant, not huge, but a significant current draw. So there's 332 milliamp draw at this moment. And that draw is enough to bring the battery down over a couple day period. I would anticipate, if everything would have been proper in this vehicle, maybe around a 20 milliamp draw. That would be very customary to a vehicle of this type, keeping all of the memories alive. But since there is a larger current draw, we're going to have to come in with a plan to determine what it is. But I wanted to show specifically this technique of doing a hookup, leaving the modules intact. This is the preferred method. You're going to need a little auxiliary battery, but this methodology in conjunction with this tool is going to be the most accurate way to go in and do your physical hookup for your parasitic draw. That's enough current to draw the system down and cause the very problem I have. Since it's not excessive amount of current, I'm going to go off with the thought that it's probably an electronic device because it's more limited in current. I have done a thorough investigation through the windows that nothing else was turned on. I didn't see any lights, I didn't see any aftermarket accessories, so that all looked good. So now I'm going to have to start doing is going through and thinking about what would be logical. And I'm going to use the approach I've used for many, many years. And simply, I'm going to take off the cover for the fuse and relay panel. Going to examine what my options are, and we're going to go ahead and we're going to start pulling fuses. Sure enough, I found a problem. It's in a radio circuit. So obviously we have a problem there that's going to have to be investigated, but at least it's down to a simple, non-complex circuit. And we'll have to take an approach here, seeing what we're going to have to replace, but at least we have found a problem at this point. So I can simply leave this fuse out and come up with a plan for corrective action. But temporarily, this will solve the problem, and long term, we'll do the repair. But I just wanted to show you how this system worked. Now that we found and fixed the problem, we'll go ahead and see what we've got here. Looks like we've got 17 milliamps. So a battery can last for weeks at that kind of a draw. So with that kind of a draw taking place, we could safely say that this vehicle is now repaired and can be put back in service, and there would be little or no risk of the battery going dead. So now we got to do is simply set it back up for disconnect, so we don't have to reset all of the radio stations. The computer doesn't have to be relearned. The transmission computer doesn't need to be relearned. So we have one last process here. And this last process is simply going back, taking our auxiliary battery, hooking it up like we had before. So now it's hooked up like we had before. I can turn this back over here. I'm going to turn it to the on position. At that point here, the meter is no longer needed. So I'll take the meter out of the equation. So we know for a fact that this is now hooked up. I can go ahead and make my disconnect. Everything's still live. I'll go ahead and put the cable back on. Now that we got the cable back on, at this point here, I simply can disconnect the parallel connection, and the vehicle can be put back in service. So for a relatively small investment of a very high quality meter, an auxiliary battery, you've got many options for that, just happens to be the one I have here, and this tool, the Parasitic Draw test harness. Between the three of them, I was able to get in very successfully. And we've done a lot of these. In fact, I think we're not done with this whole arrangement here because I have a skid steer that is drawn on a battery, and I'm going to need to take action with that too, because there's nothing more miserable than going out in the wintertime to feed the cattle and I have a dead battery or a low battery, then the skid steer doesn't want to start. So that's going to be the next item I'm going to tackle. Well, now that we got the skid steer inside and cover opened up, let's go ahead and see what's going on with the battery. I charged it overnight. I started up about a half hour ago, brought it in, and now we're ready to do our testing. So it was at, I believe, a full charge. We don't know the integrity of the battery. I checked it about a month ago, but it may have deteriorated. So the first thing we need to do is get the battery portion out of the equation. Well, coming off a fresh charge, you can see the battery integrity is really good here. But what I can see, it appears that we may be dropped. Well, as we observe, we can see the battery voltage dropping ever so slightly from coming in running, so the charging system must be working. It put a charge back in, but we see a deterioration now. So that strong indication is something is drawing the battery down. But first thing I still want to do is I want to check the battery integrity. We'll take the micro bat here and we'll do a battery test. Okay, so that's the right setting for the battery. We'll go ahead and run the test. Comes back, battery's good. No problem there. So we know we're starting with a good battery. We're not chasing our tail with a battery that's shorting out intermittently. So if it tested at that level, I think we got a good battery. Well, the next step we have to perform is I like to make sure that I keep the system intact. I think it's critical to the test. Even though there is no electronics on this older Bobcat, there still is the chance that we could disrupt something. So let's keep everything intact by simply putting an auxiliary battery in. So I'll hook up to the negative cable in the back. Since I don't have an easy auxiliary port here, I'm simply going to go over to the positive cable, get a grip on the outside. The system's now running in parallel, so I have this battery and the auxiliary battery are both carrying the system. So we'll take, at this point here, we'll disconnect positive cable. The system's still live. We're still running power through the auxiliary battery to maintain the system. Now get out this tool here, our parasitic draw test harness. Put this up in a manner that I'm going to hook to my positive battery terminal, to the cable. Make sure the switch is turned to on position. At this point, I can take off my auxiliary battery. Okay, the auxiliary battery is now taken out. We're going to put our meter in here, put our amp meter. So we're in a negative and the amp position. I'm going to go overhead and hit my switch to off. Whoa, we got 3.38 amps of current draw. That's pretty significant. That is actually very significant. So could it be something inside? We'll have to go take a look, pull some fuses, check some lights. Well, nothing was found inside. Now we're kind of getting limited on what it could be. Well, the first item I think I'm going to examine here is see the alternator. Now the engine's hot, so I don't know if I can really tell anything, but we'll go ahead and we'll disconnect the alternator. Whoa, look at that. Pretty darn significant draw coming off that alternator. I can feel a little bit of heat, even though the engine's hot, alternator's hot. I can feel a little extra heat in the back side. So the problem must be in the voltage regulator or the wiring going to it. So what we found here is we have a bad alternator. So the corrective action is going to be replace the alternator. But you can see the process here was simple. It was very easy to do the hookup, to verify. The tools worked as designed, and I now don't have to really worry about my re-hookup. I don't have to use the auxiliary battery because I don't have any memory. There's no clocks, no radio memory, there is no computers in this case. Now if there was, I would re-hook up the battery in parallel. This time here I can simply flip it over there to the on position, get my meter out of the equation. Well, hope you learned something in this episode here. You can see it's relatively straightforward. Some basic tools, harness, high quality meter, a few hand tools, and we're rapidly able to set the test up, run it accurately with a high level of confidence, and diagnose the problem. Well, I want to thank you for your time and have a most wonderful day.